Good evening, and welcome to Sleepy Space Facts. This is the place where the day softens, the night grows quiet, and the vastness of space becomes a gentle companion. If you're ready to relax, to drift into calm thoughts, and to fall asleep to soft stories of the universe, settle in. Let your breathing slow, let your shoulders loosen, and let's ease into tonight's soothing cosmic exploration. Tonight, our journey carries us far from the warmth of the inner planets to a world that tipped over long ago and never stood upright again. Uranus, the tilted planet that rolls through space like a marble on its side, quietly defying the usual patterns of the solar system. Before we travel too far, we should gently acknowledge the elephant in the room, or rather, the unfortunate name in the sky. Yes, Uranus, a name that has inspired generations of schoolroom laughter. Astronomers have tried for centuries to handle it with composure and have largely failed. But rest assured, tonight we will keep things mature. Mostly, before we begin, I would love to know where in the world you are listening from. It always amazes me to see how far these quiet journeys reach, from city apartments and country cottages to tiny rooms lit softly by starlight. So, if you would like, you may share your location in the comments below. If you enjoy these calm explorations, please do give the video a like and subscribe to the channel. It helps others discover this peaceful corner of science. And to those who are already subscribed, thank you. Your support means the world. You may also click the notification bell so you won't miss our next quiet adventure together. I do hope this video isn't so interesting that it keeps you awake. But if it does, at least you will drift off having learned something quietly wonderful about the universe. And if you enjoy anything and everything about space, you might also like my other channel, The Sleepy Astronomer, where we wander even deeper into the cosmos at an equally gentle pace. The link is in the description. So settle in, relax, and let us begin tonight's exploration. What truly happened to make a planet fall sideways? And how does a world like that continue to find its balance? Far beyond the reach of the sun's warmth lies a pale blue world that few people think about. Uranus drifts, there cold, silent, and slow, a planet so unusual it could almost be mistaken for a cosmic accident. Its tilt is so extreme that it does not spin like a top, but rolls like a sphere, turning its poles toward and away from the sun as it moves through its long, 84-year orbit. Discovered in the late 1700s, Uranus was the first planet ever found through a telescope, the first hint that the solar system was not yet complete. Its discovery widened astronomy, proving that secrets still waited beyond Saturn's familiar glow. And ever since, Uranus has remained a riddle wrapped in blue haze, too distant for easy study, too quiet for sensational headlines, yet far too strange to ignore. When the Voyager 2 spacecraft flew past in 1986, scientists expected swirling storms and vivid features like those seen on Jupiter and Neptune. Instead, they found a world of stillness, almost blank, as though time itself had slowed there. But beneath that quiet exterior lies a puzzle of ice, magnetism, an ancient history, a world knocked over by some forgotten catastrophe, still rolling along the edge of sunlight, indifferent to the passing centuries. Tonight, we will drift through that mystery, from its discovery and naming to its tilt, its seasons, its rings, and its quiet moons. We will trace the clues that hint at a massive impact long ago, explore why it glows with that gentle turquoise blue, and wonder together what future missions might yet reveal. Uranus is often overlooked, Yet it may hold the key to understanding a whole class of distant frozen worlds, not only in our solar system, but far across the galaxy. So as you settle deeper into rest, listen closely. Beneath its calm exterior, Uranus holds a story that is anything but ordinary. In the late 1700s, the universe felt much smaller than it does today. The known planets, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, had been recognized since ancient times. To most astronomers, the solar system seemed complete, tidy, and well-behaved. Saturn marked the outer edge of creation. Beyond it lay only stars, so everyone believed, but one man, working with a homemade telescope in an unassuming garden observatory, was about to change that belief forever. His name was William Herschel, a German-born musician living in England whose passion for stargazing had begun to eclipse his life as a composer. Herschel built his own telescopes from scratch, grinding mirrors by hand, polishing them by candlelight, and testing them in the cold night air. His instruments were some of the finest in the world, capable of revealing details no one had ever seen before. One night, March 13th, 1781, while scanning the constellation of Gemini, Herschel noticed a small, faint disk that did not look like a star. It appeared slightly larger through the eyepiece, with a soft, blurred edge, something no star ever showed. At first, he assumed it was a comet. That was the sensible conclusion. Comets wandered, and this object certainly seemed to be moving. Over the following nights, Herschel tracked it carefully, recording its position as it crept slowly across the background of fixed stars. But unlike a comet, it developed no tail. It did not fade. It remained steady and, strangely planet-like. Herschel began to suspect he had found something far more. Significant word of his discovery spread quickly through the small but passionate community of 18th century astronomy. Other observers, intrigued by his meticulous notes, turned their telescopes to the same point in the sky. They confirmed what he saw. This was no comet. It moved in a nearly circular orbit far beyond Saturn. The mathematics told a clear story. This was a new planet, the first one humanity had ever discovered. The realization was enormous. In a single moment, the size of the solar system had doubled. The impact of this discovery was extraordinary. In an instant, Herschel had expanded the boundaries of the known solar system. Saturn was no longer the outermost marker of creation. Something lay beyond, something colder, dimmer, and unimaginably far away. Astronomers began recalculating distances, revising tables, and redrawing the maps of the heavens. The tidy universe of classical astronomy had suddenly become more mysterious. Imagine that moment, standing in a candlelit study, ink on your fingertips, realizing that the familiar planets, those named by Romans and observed by Galileo, were not the end of the story. The universe had grown larger overnight, simply because one man looked closely at a star that behaved differently from the rest. At first, not everyone believed it. Some astronomers insisted that the object might still be a comet on an unusually circular path, but time resolved the debate. Measurements over the next months showed that it moved too slowly and too precisely to be anything but a planet. Its orbit was steady and unmistakable. Herschel had discovered a new world, the first found in all of human history. He proposed naming it Georgium Sidus, or George's Star, in honor of King George III. Such a gesture was polite at the time, especially for an astronomer hoping for royal support. But many scientists were unimpressed by the idea of a planet named George. They preferred something consistent with Mercury, Venus, Mars, Jupiter, and Saturn eventually. The name Uranus was chosen after the Greek god of the sky, the father of Saturn and the grandfather of Jupiter. The discovery was not only Herschel's triumph, it marked a turning point in human understanding. For the first time, a planet had been found not by myth or chance or naked eye observation, but by technology and careful measurement. The age of telescopic discovery had begun. Herschel became an instant celebrity. King George rewarded him with a royal stipend, allowing him to leave music and focus entirely on astronomy. He went on to discover moons, nebulae, and even helped shape early ideas of the Milky Way. But nothing ever equaled that moment when he realized the faint dot in his eyepiece was a world unknown to everyone before him. For astronomers of the time, Uranus was both a wonder and a puzzle. Its slow motion made it hard to observe, and its dim light required the best telescopes. Still, its existence opened a door. If there was a planet beyond Saturn, why not one beyond Uranus? Within decades, that question would lead to the discovery of Neptune, and later Pluto. It is easy now, with spacecraft and digital telescopes, to forget how astonishing that discovery was. In an era with no photography, no electricity, and no computers, just one man with a handmade telescope, human understanding expanded. On that cold March night in 1781, the sky quietly grew larger when Herschel realized he had found a new planet. He encountered an unexpected challenge: what to name it? All the known planets were named after ancient gods. Mercury, Venus, Mars, Jupiter, and Saturn had been recognized for centuries. But this new world needed a name, and tradition offered no rules. Herschel chose Georgium Sidis, honoring King George III. The king approved, but outside Britain, the name was met with amusement. Naming a planet after a mortal seemed out of place among the gods. French and German astronomers found it almost as if someone added a new deity named Steve. The naming debate spread. Some wanted another mythical name. Others proposed calling the planet Herschel, honoring the discoverer directly. The astronomer Johann Elot Bode suggested Uranus, since Saturn was named for the Roman god who ruled Jupiter's father. The next planet outward should be named for Saturn's father. In Greek myth, Uranus was the sky itself, ancient, primordial heavens. The logic was elegant. It completed the celestial family tree. The name slowly gained acceptance. By the early 1800s, Uranus became the planet's universal name. Herschel eventually accepted it too. In hindsight, a planet named George might have felt a little less majestic still. The name Uranus has had an interesting life. Its pronunciation has caused centuries of grins and awkward corrections. Some say Uranus. Others prefer Yooruh, Nices. A few attempt the Greek-like OO-Ra-Noos. No matter the version, the humor persists. Beneath that humor is something meaningful. Naming a world is an act of reverence and attempt to give identity to the unknown. When astronomers chose the name Uranus, they connected modern discovery with ancient mythology, blending science with timeless human imagination. The name reminds us that even as science advances, wonder remains. We still reach for myth to describe the heavens. Among all the planets that circle the sun, only one behaves as though it misunderstood the assignment. Where the other planets spin more or less upright, Uranus lies sideways. Its axis is tilted by 98 degrees. It does not spin. It rolls, Imagine a marble turning gently on its side as it orbits the Sun. That is Uranus, the cosmic outlier. For comparison, Earth tilts by about 23.5 degrees, enough to give us seasons. Saturn tilts more, Mars less. But all of them spin like tops, standing on the same table. Uranus, by contrast, is the top that fell over and kept spinning anyway. No one knows exactly how this happened, but the leading theory points to a colossal collision billions of years ago during the early chaos of the solar system. In those times, space was crowded with leftover debris moon-sized bodies and small protoplanets swirling in unstable orbits. Impacts were frequent and violent. One such object may have struck Uranus at just the right angle, knocking the entire planet onto its side. Evidence supports this. Its moons orbit in the same tilted plane, meaning the whole system was disrupted. Its magnetic field is offset and skewed, possibly shaped by the same ancient trauma. And the tilt is far too extreme to have formed gradually. Something dramatic must have happened. The result is spectacularly unusual. Because of the tilt, Uranus's poles point almost directly at the Sun for decades at a time. One hemisphere experiences 21 years of continuous sunlight, while the other endures 21 years of darkness. Then the situation reverses. A single Uranian year lasts 84 Earth years, and each season lingers for a quarter of that time. Sunrise and sunset become events measured in decades near the equator. Sunlight arrives from odd angles, sweeping low across the sky. Near the poles, the Sun can trace slow circles for years without setting. Even the magnetic field is tilted. 60 degrees off the rotational axis and does not pass through the planet's center. It wobbles and tumbles as Uranus rolls, creating a magnetosphere unlike any other. For its moons, this tilt shapes everything. They orbit in the same sideways plane, experiencing the same extreme seasons. Imagine a moon where the Sun rises once every 42 Earth years. Some scientists suggest the tilt might have developed gradually, influenced by a lost giant moon that once destabilized Uranus. Over millions of years, such a moon could have toppled the planet before being torn apart into rings and smaller satellites. Whatever the cause, Uranus remains stable in its sideways orientation. It does not drift back toward uprightness. It simply rolls quietly through space, unique and unbothered. There is something poetic in that. In a solar system of orderly spinning tops, Uranus is the one that fell and continued on its way. Time behaves differently on Uranus. Not in the sense Einstein described, there is no relativistic distortion here, but in a slower, quieter way. On this pale blue world, the rhythm of light and darkness stretches so far beyond human experience that it feels almost like another dimension, where Earth moves briskly through its days and seasons. Uranus drifts. Its orbit around the Sun takes 84 Earth years to complete. A single year there would span nearly an entire human lifetime. And because of its 98-degree tilt, this long orbit creates some of the strangest seasons in the solar system. On Earth, our modest tilt gives each hemisphere predictable cycles of daylight and shadow. But on Uranus, that same principle plays out on a monumental scale. When one of its poles leans toward the Sun, it remains in sunlight for 21 years. The opposite pole sinks into the same duration of darkness. Then, very slowly, the planet rolls onward. Reversing the situation, it is difficult to imagine how this would appear from any sort of surface. Such a surface existed. For 21 years, the Sun would hover in the sky, circling slowly along the horizon without ever setting. The light would be dim, filtered through methane haze and thin clouds. Then, after decades of this constant twilight, the sun would finally drift downward and vanish beneath the horizon, not for a night, but for an entire generation. Along the equator, time behaves differently still. There, the sun rises and sets in a rhythm closer to a normal day, but the angles are strange and shifting. Twice during each Uranian year, once every 42 Earth years, the sun aligns directly with the equator, creating long equinoxes. During these moments, the boundary between day and night falls cleanly across the planet. These are precious times for astronomers. When the sun strikes the ring's edge on, they cast thin shadows across Uranus's cloud-top stellarcade, sweeping lines stretching over the faint turquoise sphere. These rare moments reveal atmospheric patterns invisible at other times. The planet appears to awaken briefly before returning to its long, slow drift. Because Uranus moves so gradually, time there is best measured not in hours or days, but in ages. A single day lasts about 17 hours, but the tilt distorts any meaningful sense of daily cycles. Near the poles, the concept of a day is nearly meaningless, as the sun might not rise or set for decades. Near the equator, day and night occur, but stretch and shift with peculiar sluggishness. For scientists, these patterns pose fascinating challenges. The long exposure to sunlight at one pole, followed by decades of deep cold, likely drives slow-moving weather patterns deep below the clouds. Methane freezes out and sublimates in sweeping seasonal shifts, large enough to shape the entire atmosphere, yet so slow that humans have witnessed only a few fragments of these cycles. We have never observed a full Uranian season from start to finish. Our instruments capture moments separated by decades. Like a film, we see only a few frames of. The last equinox occurred in 2007, revealing new storms and faint ring shadows. And the next will not arrive until around 24/9. In this way, Uranus guards its secrets with patience. Imagine trying to understand Earth's climate by observing it for 1 week. Every 50 years, that is our level of insight into Uranus. It is also symbolic that Uranus treats time so differently. Most planets move in rhythms that feel familiar to US daylight, darkness, seasons. On Uranus, those rhythms stretch until they almost dissolve. The usual boundaries fade. Time drifts. Days are not days. Seasons are generations. Despite this slow pace, Uranus is not completely still. During its long transitions, when sunlight begins to move from one hemisphere to the other, its atmosphere stirs. Soft pastel bands appear. Thin streaks of clouds drift across its blue surface. Then, as the tilt continues and one side settles into darkness, the atmosphere cools again and the world returns to stillness. Even at its brightest, sunlight on Uranus is faint. The planet lies nearly 3 billion kilometers from the sun. Daylight resembles deep earthly twilight, dim, translucent, never harsh. So when night falls, the shift is gentle, almost imperceptible. From above, during equinox, Uranus appears half lit and half in shadow. The rings stretch across the divide, casting shadows that mark time on a planet where time moves so slowly. Colors shift subtly as light filters through layers of atmospheric haze, sliding from pale white to turquoise to dusky blue. The changes are so gradual you could watch for hours and barely see motion. The moons of Uranus experience this same slow passage of light. Orbiting in the planet's sideways equatorial plane, they too endured decades of sunlight and decades of darkness. Their icy surfaces brighten slowly under long summers, then fade into frozen shadow for years. It is a ballet of illumination, a quiet dance of moons around a sideways world. Because these cycles unfold over such vast spans of time, we may never witness them fully in a single human life. We see only glimpses, just enough to know how extraordinary they are, but not enough to understand them completely. In this cold, distant realm, change is glacial, not in motion, but in patience. Uranus has rolled through billions of such cycles, leaning gently toward and away from the sun. It is a world that refuses to rush, drifting through seasons that stretch across generations. On Uranus, sunrise and sunset do not mark the hours. They mark eras. Uranus belongs to a rare and curious class of planets known as ice giants. The name sounds dramatic, almost mythical, but it is a scientific description. In our solar system, there are 4 giant worlds: Jupiter, Saturn, Uranus, and Neptune. Yet they are not all the same. Jupiter and Saturn are gas giants, immense swirling spheres of hydrogen and helium, built mostly of the same elements that make up stars. Uranus and Neptune, however, form a different category. They are smaller, denser, and composed largely of substances that would freeze into solids or liquids under ordinary conditions: water, ammonia, and methane. These are the ice giants. Planets built from the frozen chemistry of the distant solar system, of course. Ice on Uranus does not resemble ice on Earth. There are no frozen lakes or sparkling fields of frost. Inside Uranus, temperatures and pressures are so extreme that water, methane, and ammonia behave not as familiar crystals, but as deep, pressurized fluids, exotic states of matter found nowhere on the surface of our world. If we could slice Uranus in half, its structure would look nothing like Earth's. The outermost layer is a thin shell of gas, hydrogen, and helium forming the misty blue atmosphere we see. This layer is only a small fraction of the planet's total mass. Beneath the clouds lies a vast mantle of water, ammonia, and methane ices. These do not exist as icebergs or slabs, but as hot, dense fluids compressed by enormous pressure. Deeper still lies the core rock and metal fused into a molten compressed sphere under unimaginable weight. This layered interior makes Uranus unique. The boundaries between atmosphere, mantle, and core are hazy, blending gradually rather than forming distinct layers. There is no solid surface to stand on, only a descent into steadily increasing pressure and strangeness. The deeper one imagines falling, the more alien the materials become. Yet, despite all this internal heat, Uranus is astonishingly cold. It is the coldest planet in the solar system, even colder than Neptune, which lies farther from the sun. Temperatures near the cloud tops plunge to around -224 degrees Celsius, close to the lowest temperature possible for a planet receiving sunlight at that distance. This deep cold is a mystery. Most planets, including Jupiter, Saturn, Neptune, and even Earth, radiate more heat than they receive from the sun. They glow faintly in infrared light, releasing leftover warmth from the violent days of their formation. But Uranus radiates almost no excess heat at all. It gives off barely the same amount of energy it receives, as though its internal furnace has long gone out. Why? Scientists do not know for certain. One possibility is that the same ancient impact that knocked Uranus onto its side also disrupted its internal layers, trapping heat deep inside. Another idea is that the planet's composition allows heat to escape slowly, locked behind dense layers of ice. Or perhaps Uranus simply lost its internal heat early in its history and never regained it. Whatever the reason, the result is a world that feels frozen not only in temperature, but in character, quiet, still, and deeply subdued inside Uranus. Materials reach states nearly impossible to replicate on Earth. In laboratories, scientists attempt to mimic these pressures using diamond anvils and powerful lasers. Under such extreme conditions, water transforms into something entirely unfamiliar. It becomes supersonic water, a strange phase in which oxygen atoms form a rigid lattice, while hydrogen ions flow through it, like electricity through metal. It is part solid, part liquid, and entirely extraordinary. Supersonic water may help explain many mysteries of Uranus. Because it conducts electricity, it could generate the planet's magnetic field, one that is tilted, off-center, and unpredictable. It may also create internal layers that resist mixing, helping to maintain Uranus's unusual structure. If such material truly exists deep within the planet, then at the heart of Uranus lies an ocean of glowing, electrically active ice, a restless inner sea hidden beneath serene blue clouds. That contrast defines Uranus: calm above, chaotic below. On the outside, clouds drift slowly, their motions subdued by the planet's lack of internal heat. Storms are rare and faint. Colors blend gently into one another. Yet beneath the calm exterior lies a world of shifting pressures, exotic chemistry, and flowing supersonic oceans. Even simple molecules like methane tell quiet stories. Methane absorbs red light, giving Uranus its tranquil turquoise color. In the upper atmosphere, methane condenses into delicate crystals, forming thin, high-altitude clouds that drift across the planet in faint, whisper-like layers. The deeper you imagine sinking, the stranger the environment becomes. The atmosphere thickens into dense, crushing fog. Water and ammonia merge into slushy, high-pressure fluids. Temperatures climb. Pressure rises to millions of times what we know on Earth. Deep within, the mantle may churn tortuously, generating Uranus's peculiar magnetic field. At the very center lies the rocky core, possibly no larger than Earth, gripped by enormous forces and surrounded by that vast, alien ocean. Scientists wonder how stable this world truly is. Without internal heat, why does Uranus's magnetic field remain active? How does its atmosphere continue to move, however gently? The balance seems delicate. It has endured for billions of years. In many ways, Uranus lies at the boundary of our understanding. It bridges the worlds of gas giants and rocky planets. It reveals how elements behave under unimaginable pressures. It challenges our ideas of planetary formation and internal structure. It is a world that should be simple, but is profoundly complex. And despite its immense distance, Uranus remains quiet and serene, turning slowly on its side, holding its secrets deep within. If there is a place in the solar system that embodies stillness, it might be this pale world, drifting softly through the darkness with its hidden ocean of glowing ice. In most of the solar system, magnetic fields behave predictably. They rise from deep within a planet's core, align roughly with the planet's rotation, and create steady, orderly shields that guide charged particles. Earth's magnetic field, for example, resembles a tidy bar magnet, tilted only slightly from the planet's spin. Jupiter's vast field is equally organized, forming an immense, disciplined cocoon of radiation around the giant world. But Uranus is the exception, a rebel among magnetic fields. Its invisible forces appear to have rolled sideways right along with the planet itself. When Voyager 2 arrived in 1986, scientists expected something familiar: magnetic field centered around the core, tilted only modestly, behaving in clean, structured patterns. Instead, they found something entirely unexpected. Uranus's magnetic field was wildly misaligned. It was offset from the planet's center by more than a third of its radius and tilted almost 60 degrees from its rotational axis. Nothing lined up. The geometry was lopsided. The poles were far from where they should have been. Even seasoned physicists were left puzzled. This odd structure means that Uranus's magnetosphere, the region shaped by its magnetic field, does not rotate in a neat, predictable way. Instead, as the planet rolls through space, its magnetosphere tumbles and wobbles unpredictably. Imagine holding a flashlight that isn't centered correctly in your hand. As you spin, the beam swings wildly, sometimes pointing inward, sometimes outward, sometimes looping back on itself. That is how Uranus's magnetic bubble moves through the solar wind. The source of this unusual behavior lies deep within the planet. On Earth, magnetism comes from the molten iron of the core, flowing like a dynamo. On Uranus, however, the magnetic field likely arises not from a metallic core, but from its mantle, a thick, slushy layer of water, ammonia, and methane under crushing pressure. Within this mantle, scientists suspect the presence of superionic water, strange state where oxygen atoms form a rigid structure, while hydrogen ions drift freely like electrical currents. If so, the magnetic field is being generated by exotic ices, not molten metal. And because this dynamo is located far from the planet's center, the resulting magnetic field becomes crooked and incomplete. Uranus's magnetic field is not just tilted, it is displaced. It does not pass through the center, and it shifts constantly. Because of this misalignment, Uranus's magnetic poles wander widely over its surface, sometimes pointing sideways, sometimes backward, depending on the planet's orientation. Every 17 hours, as Uranus completes a rotation, the entire magnetosphere twists, exposing different regions to the solar wind. No other planet behaves this way. Voyager 2 had only a few hours to study the field, and the fluctuating data made analysis difficult. Instruments meant to record orderly patterns found themselves reading signals that twisted and reversed abruptly. Sometimes, the magnetic tails, the long wake that trails behind a planet, did not point away from the sun at all. Instead, it spiraled behind Uranus like a corkscrew, forming an enormous curling helix stretching millions of kilometers through space. The consequences of this are profound. On Earth, auroras cluster around the magnetic poles, creating the northern and southern lights. On Uranus, the poles are so displaced that auroras appear in strange, unexpected regions, sometimes near the equator. They glow faintly in ultraviolet light, invisible to human eyes but captured by telescopes orbiting Earth. This shifting magnetosphere also means that Uranus's shielding from the solar wind is inconsistent. Some days, the field deflects particles effectively. Other days, gaps open where solar particles slip through, interacting directly with the atmosphere. In a sense, each Uranian day brings a new magnetic configuration, an ever-changing, invisible weather pattern. For scientists studying planetary magnetism, Uranus challenges long-held assumptions. Magnetic fields were once thought to require symmetries, smooth, organized, centered. Uranus shows that nature is comfortable with asymmetry, chaos, and improvisation. Its magnetism is not a tidy bar magnet, but a tilted, wandering, dynamic system shaped by layers of exotic fluid. How Uranus maintains such a field is still uncertain. Some theories propose that multiple layers within the mantle generate partial fields that combine imperfectly, creating the observed tilt. Others suggest that the ancient impact which toppled Uranus also scrambled its internal symmetry permanently. If so, the magnetic field might be a lingering scar from that primordial collision, a wound that never healed. Despite its odd geometry, the magnetic field is not weak. It is roughly as strong as Earth's, though stretched into a much larger, stranger shape by the surrounding plasma. Voyager detected a twisting magnet tail, resembling a spiraling ribbon drifting through space. Structure unlike anything else in the solar system. If we could see Uranus's magnetic field with our eyes, it would appear as a great transparent shell, shimmering and warping as the planet turns sideways beneath it. Charged particles would spiral along distorted field lines, producing faint auroras in unexpected places. Each rotation would twist the shell anew, sending ripples outward like waves formed by a tilted spinning stone in a dark cosmic pond. In a poetic way, it is fitting. Uranus's magnetic field refuses to behave, just as the planet itself refuses to spin upright. Its seasons last decades, its storms are faint, its axis lies sideways, and even its invisible heart leans off-center. Where other planets align neatly with their magnetic compasses, Uranus continues its long, graceful tumble, its magnetic field flipping, wobbling, and swirling in an endless, quiet dance. For all that we have learned, Uranus remains one of the least explored worlds in our solar system. A single spacecraft, passing by for a few fleeting hours nearly 4 decades ago, is still our only visitor. Everything we know, its sideways spin, its muted storms, its fractured moons, its wandering magnetic field, comes from that brief encounter and from distant telescopes, squinting across billions of kilometers. That this quiet neglect is changing. Scientists around the world now agree that Uranus is one of the most compelling targets for a future mission. Its strange tilt, its unique interior, its delicate rings, and its mysterious moons form a treasure trove of unanswered questions. For the first time in history, space agencies are beginning to prepare for a journey back to this pale, sideways world. The idea is simple: send an orbiter, a spacecraft designed not to pass quickly by, but to stay, to settle into orbit, to observe Uranus day after day, season after season, for years. Such a mission would transform our understanding in ways that Voyager never could. NASA has proposed the Uranus Orbiter and Probe, a mission that would deliver an orbiter to study the planet from above, and a descending probe to dive directly into the atmosphere. This probe would fall through the pale blue clouds, measuring winds, pressures, temperatures, and the composition of the gases. It would reveal layers hidden from telescopes. It would enter the atmosphere and send back data until the pressure overwhelmed it, offering the first direct taste of an ice giant's interior. The orbiter would remain above, circling Uranus, mapping its magnetosphere, scanning its faint ring system, and observing its moons up close. Ariel, Umbriel, Titania, Oberon, and Miranda would finally be seen in full detail, not just in fragments. Such a craft could watch the weather shift across decades-long seasons. It could measure heat escaping from the interior if any exists. It could study how the magnetic field twists and bends, and perhaps trace it to the layers deep below the clouds. It could search the moons for signs of hidden oceans. As hints already suggest, may exist beneath their icy crusts. Most importantly, it could begin to answer the greatest mystery. What happened that knocked Uranus onto its side? Was it one massive impact? Several smaller ones? A lost moon? A chaotic early history unlike that of any other planet? A mission like this will take time. The best launch window comes in the early 2030s, when Jupiter can help sling a spacecraft toward Uranus with a gravitational boost. Travel time would be roughly 13 years. That means an orbiter arriving in the mid-2040s slow by human scales. But a single breath in the life of a planet that drifts through 84-year seasons. It may feel distant, but missions to the outer planets are always long stories, begun by one generation and completed by the next, just as Cassini spent over a decade at Saturn. And just as the Voyagers are still flying half a century after launch, a Uranus mission would become a patient, unfolding odyssey, and the scientific rewards would be immense. Uranus represents an entire class of planets that are common in our galaxy. Around distant stars, worlds similar in size and composition to Uranus and Neptune are abundant. Perhaps the most common type of planet in the Milky Way. By studying Uranus up close, we could learn not only about our own solar system, but about countless worlds circling other suns. We could understand how ice giants form, how they evolve, how they generate magnetic fields, how they shape their moons, and how they weather the deep cold of outer space. Every discovery at Uranus would echo outward into the universe, of course. The mission is still a concept, waiting funding, approval, and final design. But it has momentum. Researchers write papers. Engineers sketch ideas. Planetary scientists argue passionately for its importance. The 2023 Decodal Survey, a guiding document for NASA's priorities, named a Uranus orbiter as the highest priority flagship mission after Mars sample return. In other words, the scientific community is ready, and perhaps it is fitting that a world so patient will be approached with patience. Uranus has waited quietly for billions of years, tilted on its side, wrapped in pale blue, drifting in darkness. It can wait a bit longer, but someday, perhaps not far from now, another spacecraft will arrive. It will fire its engines, fall gently into orbit, and begin to reveal the sideways giant as we have never seen it before. For now, Uranus remains a mystery preserved in twilight, but the next chapter is already being written, slowly, carefully, and with a quiet sense of anticipation. A world that once seemed calm, empty, and overlooked may soon become one of the most fascinating destinations in the solar system. Part 11. In many ways, Uranus feels like the quietest corner of the solar system, cold, dim, and distant. It drifts through the darkness with a slow, sideways grace, offering only the faintest hints of movement or change. And yet, in that stillness, it reveals something profound about the nature of planets, of history, and of the universe itself. Uranus reminds us that not all mysteries announce themselves loudly. Some whisper, some settle quietly at the edge of awareness, waiting for the right moment, the right observer, the right question. Its pale turquoise light is soft, almost shy, and its features require patience to understand. But hidden within that gentleness are clues to the earliest days of the solar system. When we look at Uranus, we are looking at a survivor of ancient chaos. Its sideways tilt hints at a violent past. Its cold atmosphere speaks of lost heat. Its rings are dark remnants of shattered moons. Its magnetic field twists and wanders, shaped perhaps by exotic ices deep within. Its moons hold scars of upheaval canyons, cliffs, and fractured terrains that freeze moments of ancient change. Yet today, everything appears calm, this contrast of violent origin wrapped in peaceful silence is one of the reasons Uranus is so intriguing. It is a planet that shows the aftermath rather than the event. It is the quiet after a storm that ended billions of years ago. It carries the memory, but not the motion. In that sense, Uranus is like an old photograph, beautiful, still, and full of stories no one witnessed directly. Studying Uranus is also an invitation to slow down. Its seasons last decades. Its changes unfold across human lifetimes. We cannot rush understanding here. We must observe, wait, return, and watch again. It reminds us that the universe operates on scales far gentler and far vaster than our everyday rhythms. Perhaps that is why Uranus is so well suited to sleep-friendly exploration. It is a world that moves slowly, speaks softly, and holds its secrets with quiet patience. As we drift through its details, our thoughts slow to match its pace. The mind relaxes. Curiosity becomes calm. Even its color, the soft aquamarine glow caused by methane, feels soothing. Like a distant lantern in a darkened room. Uranus also teaches humility. It shows that even in our own cosmic neighborhood, there are worlds we barely understand. For all our telescopes and technology, there are still places where mystery thrives. The outer solar system is not empty, it is simply quiet. Quiet enough that we must listen carefully, and in that quiet, we discover that Uranus is far from dull. It is strange. It is elegant. It is unexpectedly complex. A planet knocked sideways. A magnetosphere that wobbles. Rings that vanish when turned edge on. Moons that wear the names of fairies and spirits. A fractured world named Miranda that looks like a dream. Half-remembered. All of it wrapped in a stillness that seems designed for contemplation. As missions are planned and ideas circulate, we stand at the edge of a new era of discovery. Someday, a spacecraft will fall into orbit around this serene world. It will watch storms bloom and fade. It will map canyons and cliffs. It will track magnetic twists and ring shadows. It will drift past moons that have not been seen closely in nearly half a century. And when that day comes, Uranus will finally begin to tell its story, not in shouts, but in quiet, measured whispers. For now, we are left with this, a gentle blue world rolling gracefully through the dark, its secrets tucked beneath layers of ice and calm. A planet defined not by its noise, but by its stillness. A reminder that even in the vastness of space, peace exists. If you enjoyed this peaceful journey and would like to drift through more calming explorations of space and science, feel free to subscribe. Your support helps these quiet stories continue.